Hello guys, welcome back once again. You might have noticed that the last two parts actually weren't that interesting. So today is the last part, and today everything's gonna change. Why? Because today we're implementing the AI. Now you might ask, what does the AI actually do? So remember this game? Right, we made it in the last two parts. The basic concept is a human can write a level for it, the game loads the level, and a human can play the level. But today, we're not gonna make the levels ourselves, but instead use an AI. Imagine the AI like a human. It has some kind of vision, and it sees what it just has done. It also has hands to place a block and write everything into a file. Oh, and it also sees some shady value between 0 and 1. Actually, all the values it sees are between 0 and 1. This is called the input layer. It's like a pyramid. The input is on the left, the output is on the right. All these nodes are connected with a string. And actually there are many strings, and also every string has a weight attached to it. Also, it's important to know that every node has a value between 0 and 1. And the formula for the whole node, for example if we see this one as node A2, will be the sigmoid function, which I'll explain later, of something. And the something is actually the weight times the previous node. So obviously we will have a weight 1, weight 2 and so on. The first input will be a value, and it will kind of tell the AI if the player has already spawned. The next one will be the x and y coordinates of the previous block, and the next two will also be the inputs of the block before the previous block. So basically, when the AI has drawn two blocks, it will see exactly those two blocks. So I already started, and I made a program which basically makes an array, which is one-dimensional, of 3 elements. Well, it's basically strings of data, and we can add to them if we want, or we can also not add something. Which is good, because this will actually represent our neural net. So this piece of code right here basically does create the network and makes it look like this. So I just stumbled across this right here, where I need to implement the sigmoid function. Now the sigmoid function actually takes a value between -infinity and +infinity and turns it into a value between -1 and +1. Now this right here is not the sigmoid function, but this here is the actual function. So apparently computing of this function is very slow, and this one is a approximated version of the sigmoid function, which looks like this. So I think I'm going to use this one. Okay, here we go. So I made this beautiful illustration right here, which basically shows us how the weights are applied. As you know, each path from node to node has a special weight to it. So from the first to the second layer, you've got 5 weights, these 5 right here, multiplied by 4 because we have got 4 nodes. So there are 25 weights involved in the creation of these nodes right here. So obviously this is the proportion property of the second layer. From the second to the third, we have got these 4 nodes. So that's 4 weights each, and we have that 3 times. So that's 12 weights, which is property of the third layer. So you can kind of imagine the weights like a matrix, and you can basically think of a spreadsheet. Who needs access to the weights, as in which node, node 1, node 2, and so on, and from which node does the value come from, and then there's a specific weight. And now imagine the whole thing kind of 3-dimensional, since we have multiple layers. The previous block variable gets assigned to the new output. Also, the new output gets stored once again, multiplied by the pixels of the game itself, and then gets printed. So let's have a look at it, shall we? Oh my god, it actually compiled. Okay, for some reason this whole loop didn't stop. For some reason I created an endless loop. So of course this level wouldn't work, but just for fun, let's write it into a file. Now let's see what this looks like in real life. Moment of truth, and oh yeah, beautiful. Like, what the hell happened here? Okay, so I was actually able to output the outputs of the neural net into different files going from 0 to 9. But now we need a program to evaluate those files, so I'm doing that right now. So for now, we're gonna start with seeing how many overlappings we have got in our whole map and crediting the file based on that. Okay, so apparently we've got 231 overlaps with just 26 blocks. I mean, that's amazing. Okay, so I now have written 100 levels. Let's see what's the best one. Alright, let's have a look. There's 90, there's 54, there's 50, 51, there's 18. So let's have a look at level 50.txt. Let's see. Those are pretty few overlaps actually. So my goal for now is to make the AI actually learn. For this I'm gonna use arguments passed by the shell. And I actually never have done this before, so I'm just gonna try it out. Okay, so if everything goes according to plan, we should now be dumping the entire brain into our files. Let's see. So all these are the level files, and then here the weight files start. So we can now actually evaluate all the levels, and here we can see most overlaps in file 36, now file 23, and those are the weights. So we can now take weights 23, and then take that and kind of mutate the brain based on this. Okay, so we are now able to load the files. We're now able to load the weights from a file, so we could possibly reproduce a good output, but the rest will actually be random. So let's now get to the mutating part, where basically we only change the values by some number between -1 and 1 divided by 4. So the biggest possible change is actually plus or minus 0.5. To give you a short recap, what we have done was to output each weight into different files. So these are these ones. And we have also picked the best weight file and are now able to load it back in. And now we can actually evolve this neural net. So let's give it a go. And we're done. So this is the second generation already. And we can have a look at file 71, which is also the suggested file. And I mean, it looks kind of good, but still not really kind of good. Here we go, third generation. So 46 was apparently best. Let's have a look. I mean, yeah, that's better. Let's have a look at 85. Oh, this is looking good. It is actually quite good. This is the best so far. Now 140. The best so far. Let me stop you right there. I know that this is not a fully fledged AI, since it requires constant human input. However, automation of this all is very simple. If a program would do that, we in fact would be close to getting a functional AI. Another thing, our feedback loop is far from perfect. In fact, the AI found a way to trick us. It realized that it only needs to read the first and last blocks apart, not regarding the overlaps. This is due to a poor evaluation algorithm. This is why a proper feedback loop is so important. So for me, I consider this project done. There's still a lot of work regarding editing and uploading. Maybe I'll come back to this in the future and go off with a clean start. Until then, best regards and see ya!